Alright guys, so I scrolled down. I actually added the sum formula. We're not going to use it yet, but we are going to use it after number 5 and 6 when we get to 7. So I wanted to go ahead and write it down. I wouldn't write it right there. If this was your paper, I would write it right here, but I'm going to scroll and it's going to show up right here. So if you want to write the sum formula, I would write it like right here because that's the formula we're going to use for those problems. I just know I'm going to scroll in a couple minutes, okay? So we're still going to use the sequence formula where we're still just trying to find the list, or we're using the lists. When I look here, A-N, A1, R, and N. Again, these are just lists. We're not adding anything up. That's how I know to use this formula, okay? So the last term is 48. The first term is 7. And I do know the number of terms, 1, 2, 3, 4, 5. So there's 5 terms total. So that means I'm finding the ratio. Remember, whenever it says means, that means the numbers between the beginning and the end. So you could also hear the phrase, find the 3 geometric means between 7 and 48, okay? And that means the 3 numbers that are evenly spaced between 7 and 48. So we got to find the ratio to know what are we multiplying by to get from 7 up to 48. And I think one of these might have a typo, if I remember correctly, so we might get a decimal for one of these. We'll see. So let's use our formula. 48 equals 7 times the ratio 5 minus 1. Okay, so 48 equals 7 times r to the 4th. Well, divide both sides by 7 because we want r to the 4th by itself. I think this, again, this is the one where we have a decimal. Yeah, 6.86. So we'll round. Okay, and then the opposite of the 4th power, this is why we did it, is remember the 4th root. So if I take the 4th root of this, 4 to the root of 6.86, is that right? Yep. I get about 1.62. So the ratio is about 1.62, which is weird. We should get a regular ratio. This isn't going to be a fraction because since we square rooted, that root makes it irrational. But we can work with it. So 7 times 1.62 is 11.34. Okay, if I multiply that by 1.62, I get 18.37. And if I multiply that by 1.62, I get 29.76. And then if I multiply that times 1.62, I get 48.2, which is very close. And since we got a decimal, since it was a little weird, we did get close. And that's what we want. It needs to go from beginning to end. So there was a typo. I'm not exactly sure if it was the beginning or the end. So we'll just work with that, okay? Number 6. This is probably hard to see on the board, but on your paper it's -2. So you can tell that. Let's go through. I know the reds show up well. So a to the n, a to the 1, r, and n. I just know it's a little hard to see, so that's why I wrote it a little bit lower. The last term is -162. The first term is -2. The ratio is what we don't know. 1, 2, 3, 4, 5. 5 terms. The 3 geometric means between those two. Okay, so again, I'm going to use the formula. The first term times the ratio to 5 minus 1. So both of these happen to have a 4th power. If you automatically know that it's -1, you can just put in a 4. You can quicken this up a little bit. Actually, I will. I'm going to go ahead. I'm going to divide by 2. Oh, adjusted the wrong thing. negative 81. I'm going to divide by, a negative 2. So that makes it a positive 81 and r to the 4th. Okay? That way the sign goes away. All right, because if you notice, it's starting negative, but it gets to be a lower negative, so it just keeps getting less and less and less. So now the 4th root on both sides, so that they cancel out. The 4th root of 81, we had that list off to the side, is the number 3. Okay, now that isn't the final answer, but that is what we're multiplying by. So negative 2 times that 3 is negative 6. I know that might be a little hard to see. Negative 6 times that 3 is negative 18. Negative 18 times that 3 is negative 54. And then negative 54, I'm just double checking, times 3 is negative 162. So it does work out. We're multiplying everything by 3, and then that keeps everything negative, so it just gets to be a lower negative, okay? So that one helped make a little bit more sense. So now I'm going to scroll, and we're going to work on series, and that is what this equation is for, because it's summation. We're going to be adding up all of these huge numbers. We're going to get even bigger numbers, okay? So okay, so now we're going to use this formula. So now I would put this formula right here. That way you can refer to it and you know that that's what we're using for these 4 problems, okay? Again, it's just a formula. You have to do a power, but you don't have to take anything away. So hopefully this actually goes a little bit easier, maybe a little bit smoother. So let's list what we need. So we've got the sum, we've got the first term. I'm going to list left to right just because these are long skinny boxes. So the ratio and the number of terms. So those are the parts of the formula. So the first term is 3, the ratio is 2, and the number of terms is 50. So that means I'm finding the sum. So I'm just going to plug it into the formula. It equals, it's a big old fraction, 3 times 1 minus 2 to the 50. It's a huge number. And then it's over 1 minus the ratio, which is 2. Okay, so I'm just going to go through 1 minus 2 to the 50 is a huge number. I'm just making sure I put the right formula up. You don't take anything away. Nope, that's it. Times 3. I'm going to go ahead and multiply times 3. It's this huge number. Divide by negative 1. Oh, I don't like... It's even in normal. Alright, this ends up being such a huge number that even my graphing calculator is making it like scientific notation. So what I want to do is I want to actually change this number. That way it's a little bit more feasible to write. So instead of 50, let's change this to 15. Okay, that way it'll be a little bit more reasonable when we put it into our calculator and when we work it out, okay? That way, oh, sorry. It works just a little bit better so we can understand the formula better, okay? So let's use 15 instead of 50. So let me clear that out. So 1 minus 2 to the 15. It's a big number, but we can work with it. 3 times negative 32,767. When we start talking about powers, when our formulas start having powers, that's why the numbers start getting so big. And then 1 minus 2 we know is negative 1. So now I'm just going to multiply that by 3. and divide by -1, which will change its sign. So the final answer is 98,301. So what this means is if you start at the number 3 and you start multiplying by 2, 3, and then you multiply by 2, you get 6. Multiply by 2, you get 12. Multiply by 2, you get 24, 48. You keep going. Okay, not only do you get this huge list and you go out to 15 numbers, but we add all of those up, and that's why it's such a big number. Because since we're multiplying by 2, it's exponential. It's going to get large pretty quick, but then those large numbers are also going to add. Okay, and that's why instead of going out to 15 numbers, we're just going out to 15, and it's still a huge number. So, okay, let's use the formula to try and answer this question. Find the sum, so we're going to use the formula, of the first 5 terms. So, sum is what we're finding. The first term, the ratio, and the number of terms. The nice thing is that we don't actually need the last term like our other formula. So the first term is 1/2. The number of terms is 5. And then the ratio. Well, what are we doing? We're going down. We're actually going down. Okay, because it's going from 1/2 to 1/4 to 1/8. But the way it's going down is by 1/2. This is doubling, but this isn't. So that means we're actually multiplying by 1/2. We're cutting each of those fractions in half. And since it's going positive, negative, it's a -1/2. Okay? If you want to use a decimal in the formula, that's fine. So S sub n, the formula is the first term, which I'll go ahead and say 0.5. That way it's just a little bit easier to read. Times 1 minus the ratio, which is -0.5 to the 5th power, over 1 minus the ratio, which is 0.5. Okay? So I did this on purpose because this might not change, or it might. It all depends on what the power does. But if you put that into your calculator the way it looks, you're going to be accurate when you get the output. Okay? So it's 1 minus -0.5 to the 5th power. Oops. That's 1.03125. And then I'm going to multiply that by 0.5. I'm just trying to... So 1.03125, that's a fraction. And then 1 minus 0.5 is just 0.5. It's a half. So 0.5 times that I already got. I'm going to divide that by 0.5, and I get this back out because those actually cancel. So I get 1.0325, which 3125 is a fraction. If I go math, enter, I get 33 over 32. So if we had left it a fraction, we would have kept it as a fraction. Okay. So not only do you have all of those, but when you add them up, and I'm wondering if I'm upside down. There's something a little funny about that. So I'll go back and I'll look at that. Okay. I'll go back and I'll double check that. If I'm wrong, we'll check it in class and I'll fix it for us. Oh, I know what I did wrong. Well, that should be negative. No. I'll go back and I'll double check myself. Okay. These, remember, the sigma means sum. And the way that we know to use the geometric formula is that the formulas, the rules, have powers. If you have powers, then that is a sign that we need to use the geometric formula, because that's where powers have started showing up. Okay, but we approach it the same way. So we still are looking for the sum, the first term, the ratio, and the number of terms. Well, this is just a little bit different in that the sum is what we're trying to find. The first term is when you put 1 in here. So that's 2 times 3 to the 0. Well, anything to the 0 power is the number 1. So the first term is just 2. Usually the first term is that number in front of the parentheses. The ratio is always the number with the parentheses. It's the one with the power. And then the number of terms are going from 1 to 6. So first term, second term, third term, fourth term, fifth term. There's 6 terms. You could go from like 2 to 4, and then that'd be different. So that's how we find out our values. Now we plug it into the formula. The first term, which is 2, times 1 minus 3 to the 6th power over 1 minus the ratio, which is 3. So this is a lot nicer. There's no decimals or fractions. So 1 minus 3 to the 6th. That is 2 times negative 728 divided by negative 2. Well, that 2 and that 2 cancel out. We did that last class. And that really is just a negative 1. So really, this negative 1 just changes the sign, so it's positive 728. If you wanted to, you could have multiplied it by 2 and then divided by negative 2, but I know that we talked about how things cancel, so that just kind of relates to last unit. All right, the last one. All right, same thing. What's the sum? So I'm going to put that up here. That way I've got a little bit more room. The first term we have to find. The ratio and the number of terms are actually given right here, okay? The ratio is the number with the power. So the ratio is 1/2. I'm going to use 0.5. The number of terms is from 1 to 10. So if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10. The first term is when we put in a 1 right here. Well, 1/2 to the 0, because that'd be 1 minus 1, which is 0, is just 1. Okay? So here's the first term, there's the ratio, there's the number of terms. So the sum is the first term times 1 minus 0.5 to the 10th power. All over 1 minus 0.5 or 1/2. So 1 minus 0.5 to the 10th is a big old decimal. Let me see. It will give me, nope, it doesn't even like it as a fraction. But it's times 1, so it's 0.9990234. All over 1 minus 0.5 is just 0.5. So if I divide that by 1/2, it's almost the number 2. It's 1.998, which we could round up to the number 2. Because since we have fractions, it always kind of rounds things a little bit, kind of like this one. And so if we were to take 1/2 to the 10th power, it would probably work it out a little bit more accurately for us, okay? So the reason why this is harder is because not only is our formula fraction, but it also has powers. So we've got to be careful when we have to put in fractions, like we did here, and when we take them to those high powers. The numbers start getting a little crazy, but we just keep cranking it out until it all comes back together as a final answer. And again, I'll double check this one. From what I can see up here, it looks like it's okay, but I'll double check it just so that I make sure we didn't steer anything wrong, okay? All right.